Okay, so today we'll see the integration of let's say p1 pi to p2 pi mod of sine x dx, or p1 pi to p2 pi mod of cos x dx, and p1 pi to p2 pi mod of sine of ax plus b dx. Okay, the p1 and p2 are not integers. So we have already done the cases where p1 and where these integrals are integers in the previous videos. In previous video we have shown that if n1 and n2 are integers, then we can write n1 pi to n2 pi mod of sine x dx is same as n1 pi to n2 pi mod of cos x dx, that is given by n2 minus n1 into 2, whereas n1 pi to n2 pi mod of a sin x plus minus b cos x dx can be written as n2 minus n1 into root of a square plus b square into 2. This is similar to, we can also say that if we have something n1 pi to n2 pi mod of sine x plus alpha minus alpha also dx is same as n2 minus n1 into 2. Here this is useful if the coefficient of x is 1. So in the previous video we have done this: if n1 n2 are integers, then n1 pi to n2 pi sin x mod of sin x mod of cos x is very easy, n2 minus n1 into 2, and n1 pi to n2 pi mod of a sin x plus minus b cos x dx is n2 minus n1 root of a square b square into 2. So today we will see what will happen if the same cases where this lower limit and upper limit are not the integral multiple of pi. So we will see that formula. Let's say 0 to p1 pi mod of p1 pi is written as n1 pi plus alpha, where n1 is integer, so here n1 is an integer and alpha is from 0 to pi. Mind it, alpha is from 0 to pi, then this can be written as n1 into 2 plus 1 minus cos alpha. Okay, and if we have a 0 to, let's say, p1 pi mod of cos x dx, that if we write p1 pi as n1 pi plus alpha, and here is alpha from 0 to pi by 2, then this answer is n1 into 2 plus sine alpha. Okay, so for sine we have this integral, and for cos we have this integral. Okay, and here we have to show that alpha is from 0 to pi by 2 for cos case, and alpha is 0 to pi in case of sine case. Why? Because mod of sin x is equal to sin x positive for x 0 to pi, that is in the first and second quadrant, whereas mod of cos x is equal to positive, that is cos x only if x is from 0 to pi by 2, that is in the first quadrant. That's why we'll see in the proof in the at the end. So but we should be sure that if it integrating cos x mod cos x, then alpha should be 0 to pi by 2, and if we are integrating the sine, then alpha should be 0 to pi, and for sine we have 1 minus cos alpha, and for cos we have a sine alpha. Okay, so let's take few examples. Let's say 0 to 5 pi by 4 mod of sine x dx. Here upper limit is 5 pi by 4, so pi plus pi by 4. So pi will be n1 into pi, so that is n1 is 1, so that is just a 2, and pi by 4, since it is a sine function and pi by 4 is 0 to pi, that becomes 1 minus cos of pi by 4, that becomes 3 minus 1 by root 2. Okay. Okay. Now again, let's take something 3 pi by 4 to 16 pi by 3 mod of sine x dx. Here upper limit minus lower limit. What is upper limit? 16 pi by 3 minus 3 pi by 4. So we'll break the 16 pi by 3 into n1 plus pi form. That becomes 5 pi plus pi by 3 minus 3 pi by 4 means pi minus pi by 4. Okay, now we'll write 5 pi means 5 into 2 plus pi by 3 means, and since it is sine function, pi by 3 means 1 minus cos of pi by 3 minus, this is pi, that means we have a 2, and minus this is pi by 4. Pi by 4 means it is a sine, and this is pi by 4 which is from 0 to pi, so again this is 1 minus cos of pi by 4. That becomes 10 plus 1 cos pi by 4 means 1 by 2 minus 2 plus 1 minus cos pi by 4 means 1 by root 2. So the answer is 10 to 10, 20, 19 by 2 minus 1 by root 2. So that is the answer. Okay. 25 pi by 2 mod of sine x dx. So again this is upper limit 25 pi by 2, so that becomes we can, so 25 pi by 2, that can be written as 12 pi plus pi by 2. So this is 12 to 24, yeah, so that becomes 12 pi means 12 into 2 plus pi by 2 means, and this is since it's a sine function, so pi by 2 means 1 minus cos of pi by 2, that becomes 24 x 25. Let's take one more example, minus pi by 3 to 3 pi by 4 mod of sine x dx. Again upper limit minus lower limit. Upper limit is 3 pi by 4, lower limit is minus of minus pi by 3. We can make it positive, so 3 pi by 4 plus pi by 3. Okay, minus minus plus. Now this is pi minus pi by 4 plus this is pi by 3. So pi means 2 minus pi by 4 means 1 minus cos of pi by 4. Why? Because this is sine, so 1 minus cos alpha, plus this is again pi by 3 is from 0 to alpha, so this is 0 plus 0 pi plus alpha, so 0 is there, so we have to just integrate pi by 3 which is from 0 to pi, that becomes 1 minus cos of pi by 3, that becomes 2 minus 1 plus cos pi by 4 1 by root 2 plus 1 minus cos pi by 3 is 1 by 2, so that becomes 2 2 ja 4, that is 3 by 2 plus 1 by root 2, that is the answer. Okay, let's take relative cos. Let's say this is pi by 3, so this up 5 pi by 2 mod of cos x dx. So that becomes, we have upper limit is 5 pi by 2, lower limit is pi by 3, that means pi, so that's 2 pi plus pi by 2 minus pi by 3. So 2 pi means 2 into 2, pi by 2 means since this, and since it is a cos function, so that means we have a sine pi by 2 minus, since it is a cos function, so its integration will be sine alpha, and here the alpha should be 0 to pi by 2, so here's pi by 3 means it is between 0 to pi by 2, it becomes sine of pi by 3, so that becomes 4x5 minus root 3 by 2, so that is the answer. Let's take one more example, minus 5 pi by 6 plus 3 pi by 4 mod of cos x dx. So again we have a upper limit minus lower limit, so upper limit means pi minus pi by 4, and so this is 3 pi by 4 is the upper limit, lower limit is minus 5 pi by 6, that becomes 3 pi by 4 plus 5 pi by 6. Okay, minus minus multiplied, that becomes pi minus pi by 4. This is this is sine pi by 4 plus this pi means 2 minus sine pi by 6, so that becomes 4 minus sine pi by 4 is 1 by root 2, and this is sine pi by 6 means minus half, so that means 7 by 2 minus 1 by root 2. That is the answer. Let's see, minus 17 pi by 3 to 5 pi by 6 mod of sine x plus pi by 6 dx. Okay, here since this is not in standard form, and also these are not integral. Okay, so mind it, before that, if I say let's say 0 to 3 pi mod of sine x plus pi by 6 dx, clearly here 3 pi and 0 are integer, and the coefficient of x is 1, we can directly write its answer is 3 minus 0, that is 3, into 2, that is 6. But what if these limits are non-integral multiple of that? From 0 to 3 pi, if 3 pi and 0 are integer, then it's fine, we can directly multiply 3 minus 0 into 2, as we have discussed in the starting of lecture. But what if the limits are non-integral multiple of pi? In this case, the trick is, so mind the trick. What is the important trick? Trick means not formula, trick means the concept. That means x plus pi by 6 is equal to t, so that becomes dx is equals to dt. So now our t, so obviously minus 17 pi by 6, so if I take x equal to minus 17 pi by 3 plus pi by 6, so it becomes minus 17 pi by 3 plus pi, and upper limit is 5 pi by 6 plus pi by 6 mod of sine t, and dx is equal to d, so this becomes dt. Okay, so now it's converted into standard form, and we use the upper limit minus lower limit. So the upper limit is 5 pi by 6 plus pi by 6 minus lower limit is minus 17 pi by 3 plus pi by 6. So this is 5 pi by 6 plus pi, that becomes pi, very easy, and this minus minus we can take plus, so that becomes 17 pi by 6 minus pi by 6, sorry, 17 pi by 3, so that becomes pi plus 17 means 6 pi plus 17 minus pi by 3 minus pi by 6, so this is pi plus 6 pi minus pi by 2. Okay, now since we are integrating the sine function, so obviously pi means 2 plus, again this is 6 pi, so 6 pi means 6 into 2 minus, since we are dealing with the sine function and pi by 2 is value from 0 to pi, so we can write it's a 1 minus cos of pi by 2, so that becomes 12, 13, 14 minus 1, that is the 13. So that is the answer. So let's take one more example. 0 to 100 pi 1 plus cos x dx. Okay, so how do we solve? It's not a modulus function, but still if you look at this problem, it's just convertible into modulus function. How? So we can say that we know that cos 2x is equal to 2 cos square x minus 1. So what if cos x is equal to 2 cos square x by 2 minus 1, so 1 plus cos x is equal to 2 cos square x by 2, that means we will take root, so 1 plus cos x root is equal to root 2 mod of it will be root of cos square x by 2, that is nothing but root 2 mod of cos x by 2. So I think you should know that x square root is mod of x. Okay, this is the one of the property. So now we integrated something 0 to 100 pi, this is root 2 mod of cos x by 2 dx. So root 2 we can take outside, 0 to 100 pi cos of x by 2 dx. Now clearly we see that this is not a standard form. Standard form is mod of cos x. Here it's x by 2. So what I do, simple trick which I've explained, cos, we assume x by 2 is equal to t. That means dx is equal to 2 dt. That becomes root 2, and our t will varies from 0, because if I say x is equal to 0, t will be 0. If x is equal to 100 pi, t will be 50 pi. So that becomes 50 pi, and that is mod of cos t. In place of dx we have a 2 dt. That becomes 2 root 2, 0 to 50 pi mod of cos t dt. That becomes 2 root 2, and this 50 pi minus 100, that becomes 50 into 2. So the integration of this part is 50 into 2. That becomes 200 root 2. So that is the answer. Let's quickly see the proof why we are getting that answer. So proof. So just let's prove that 0 to p1 pi mod of sine x dx is equal to it is what we have to prove, that it is nothing but n1 pi plus alpha. So the integral, this integral will be n1 into 2 plus 1 minus cos alpha, and mind it, alpha is from 0 to pi. So let's quickly prove it. Okay, if the p1 pi is equal to n1 pi plus alpha, we can write this form as 0 to n1 pi plus alpha mod of sine x dx is equal to 0 to n1 pi mod of sine x dx plus n1 pi to n1 pi plus alpha mod of sine x dx. Okay, now this is n1 into 2 we already, and this is something 0 to alpha mod of sine x dx. Okay, now we know that this is one of the property of a definite integral. The property of definite integral is that integral multi nt plus alpha fx dx is equal to 0 to alpha fx dx, where fx is a periodic function with period t and n is a integer. Okay, so same way here in this case we know that this so in this case we observe that n1 pi plus n1 pi to n1 pi plus 2, that can be written as 0 to alpha. Why? Because again, because mod of sine x is a periodic function with period pi. Okay, so the same property, n1 pi to n1 pi plus alpha, its a period is pi, so we can write it's a 0 to alpha. Now our problem converts into n1 into 2 plus 0 to alpha mod of sine x dx. Now we know that alpha is from 0 to pi. Since alpha is from 0 to pi, mod of sine x is positive, because this is the first and second quadrant, and first and second quadrant sine is positive. So the problem convert into n1 into 2 plus 0 to alpha sine x dx. So I have removed the modulus because alpha is from 0 to pi. So between 0 to pi, mod of sine x is positive. So mod of sine x will be sine x. We know that mod of x is equal to f if x is positive. This is minus x if x is negative. This is the how we break the modulus function. So this is n1 into 2 plus its integration will be minus cos alpha, and from 0 to alpha we'll substitute the value minus cos alpha minus cos 0 is 1. So we have a n1 into 2 minus plus 1 minus cos alpha. So this is how we integrate this part, and this is hence we prove. So this is n1 into 2 plus 1 minus cos alpha, where p1 pi is written as n1 pi plus alpha, and alpha is from 0 to pi by 2. So hence proof. Okay, similarly we can prove for the cos alpha. So we can, let's have a quickly we prove that 0 to p1 pi mod of cos x dx is equal to where p1 pi is written as n1 pi plus alpha, where alpha is from 0 to pi by 2 is n1 into 2 plus sine alpha. Okay, so quickly, since p1 pi is equal to n1 pi plus alpha, we can write it's nothing but 0 to n1 pi plus alpha mod of cos x dx, and that is 0 to n1 pi mod of cos x dx plus n1 pi to n1 pi plus alpha mod of cos x dx, as we have done in the previous case. So this is n1 pi, that's nothing but n1 into 2, and this is nothing but 0 to alpha mod of cos x dx. Why? Because the property of a definite integral, that n1 pi plus n to n1 pi plus alpha, where the mod cos x is a periodic function with period. So again, this is a periodic function with period pi, and since n1 is integer, so n1 pi to n1 pi plus alpha, that is nothing but 0 to alpha mod of cos x. And since alpha is from, we have already discussed that since alpha is from 0 to pi by 2, so that's why we can write it 0 to alpha cos x dx, because alpha is 0 to pi by 2, and 0 to pi by 2 the and 0 to pi by 2 cos x is positive, that's why mod cos x will be cos x, and this is same as n1 into 2 plus. That means we have n1 into 2, and integration of cos alpha is a sine integration of cos x is sine x, we put from 0 to alpha, so that is nothing but n1 into 2 plus sine alpha. So that's why the integration of 0 to p1 pi mod of cos x dx is n1 into 2 plus sine alpha, where alpha is important, that p1 pi is written as n1 pi plus alpha, where alpha is from 0 to pi by 2. Okay, then only this modulus of cos x convert into cos x. Okay, there is one more thing. Last time we have not proved it in the previous video, so we can quickly prove it. That let's say if I say n1 pi plus n2 pi mod of a sin x plus minus b cos x dx, this is where n2 and n1 integers, so n2 minus n1 a square plus b square root into 2. So we will quickly prove it. So we know that a sin x plus minus b cos x is a square plus b square root a upon a square plus b square root sin x plus minus b upon a square plus b square root cos x. So cos x. Now we a square upon root of a square can be assumed as a sin alpha, and this can be written as, again as a cos alpha. So our this problem is a square plus b square root sin x plus alpha. Okay, so our integral will convert into n1 pi to n2 pi a square plus b square root sin x plus alpha dx modulus. Now a square b square positive, so a square plus b square is positive, we can take it outside from modulus, and in fact it's a constant, so we can be taken from outside the integral. So n1 pi, so n2 pi sin x plus alpha modulus dx. Again here the coefficient of x is 1, so we can directly write it a square plus b square. So if you want, let's have a quickly prove it why I'm saying. So again I can say x plus alpha is equal to 2t, so dx is equal to dt, so that a square plus b square is a constant, it's convert into n1 pi, so will t varies n1 pi to alpha, so n2 pi plus alpha sine of t dt. Okay, and this is a square plus b square root n1 pi to n2 pi mod of sine t dt. So this is one of the, we know that one of the property of a definite integral, that is periodic property of definite integral, that n1 t plus let's say alpha to n2t plus alpha fx dx is n1t to n2t fx dx if fx is a periodic function with period t. So if n1t to n22 plus alpha, alpha is something constant added in both upper limit and lower limit, so we can remove that one and it becomes n12 to n22. Okay, so now I can, this nothing but a square, so now it's a square plus b square root, this is n2 minus n1 into 2. This is, hence we prove the formula. So one last approach, if we want to integrate any function, let's say anything, let's say you are integrating from a to b, mod of sine, let's say cx plus d dx will convert into, let's say, e to f mod of sine t dt, and it's easy to integrate. How? So we assume cx plus d is equal to t, so that becomes c dx is equal to dt. So our integral will be something cx. So if t varies from x, so a c plus d, and it is again b c plus d. And this is in place of this is sine t, and in place of dx we have a dt by c. So this is 1 by c ac plus d bc plus d mod of sine t dt. Now this is easy, we know that it's easy to integrate, and here will break. So this is 1 by c, so 1 by c, and upper limit is, so this upper limit minus lower limit, so we'll how to solve this. 1 by c is already, so how to solve such problems? We know that this is 1 by c is already there, so this is the upper limit minus lower limit, so that means bc plus d minus ac plus d, so will break in the, this form will break something n1 pi plus alpha minus n2 pi plus beta. Okay, and 1 by c is already there, so it will be, and we assume that alpha is from 0 to pi and beta is also from 0 to pi, that becomes 1 by c n1 pi, so n1 into 2 plus alpha, that means 1 minus cos alpha minus n2, so n2 into 2 plus beta means 1 minus cos beta. Okay, so this is bracket. So this is how we integrate any general case which involving the a to b sin cx plus t. Okay, okay, so I'm ending the class here. If you find it's good, subscribe the channel, you can like the videos, that will encourage me to make any, that will encourage me to upload